Today we're going to be looking at Bernoulli differential equations of this type here, and what makes this a Bernoulli differential equation is that it has here a y to the power of alpha, which otherwise would have meant that it would be of the form dy dx add f of x y equals g of x, which we already know how to solve because we've done a few videos on that, and if you haven't seen it, check out the link in the description to this video, how to solve first order non-homogeneous differential equations. Okay, so what we need to do is we need to deal with this pesky y squared in order to get this equation into this form so that we know how to solve it. Okay, so what we're going to do is we're going to do a substitution, but first of all, let's just get rid of the y squared by dividing. So we get 1 over y squared dy dx add 2 over x times 1 over y equals x squared sine x. Okay, now what we're going to do is we're going to do substitution. We're going to let v equal y to the power of 1 minus alpha, where alpha is the power of y in the equation. Well, in this case it's 2, so therefore we're going to let v equal y to the power of minus 1. When we differentiate that, we get dv dx equals minus 1 over y squared times dy dx, and just moving the minus across, we get minus dv dx is 1 over y squared times dy dx. And now what we can do is we can substitute that into here, so we get minus dv dx add 2 over x times, well, 1 over y is basically v equals x squared sine x, and just getting rid of that minus, we then get dv dx minus 2 over x times v equals minus x squared sine x, and this is now in the correct form here so that we can solve it by the method that we've already gone through in a previous video. Okay, so the integrating factor is going to be e to the minus integral 2 over x dx, which equals e to the minus 2 log x, which equals e to the log of x to the minus 2, which equals 1 over x squared. So multiplying everything by 1 over x squared, we get 1 over x squared dv dx minus 2 over x cubed times v equals, unfortunately that x squared now cancels, minus sine x. When we integrate both sides of this with respect to x, this bit we know, because that's the whole point of the integrating factor, this becomes v times 1 over x squared, and that's, well, the integral of minus sine x is cos x plus c, so therefore we have v equals x squared cos x plus c. Now we know that v is 1 over y, so now we can put our y back in, so that means 1 over y is x squared cos x add c, i.e. y equals 1 over x squared cos x add c. Now all we need to do to find the c is the initial condition was that when x was pi over 2, y equaled 1. So all we've got to do is stick those into there, and that gives us that 1 equals 1 over pi squared over 4, 0 and c, i.e. c equals 4 over pi squared, and therefore our solution is y equals 1 over x squared cos x add 4 over pi squared, and that is the solution to the Bernoulli differential equation. Well, if you found this useful, please press the little thumbs up button, and please subscribe to the Gresty Academy YouTube channel. Thank you.